will transfer to the radical. Okay, so the question is, will 3 electron will go to carbon or oxygen? Okay, so in order to solve this, children, we will make a bracket only in radical, children. Okay, so 2 will come here and 3 will, when it comes here, Al2CO. Hello dear students, today we are going to study the new topic of chapter 3, that is writing of chemical formula. Okay, children, this topic is very important for you because this topic will help you to understand chemical reactions and equations which you study in further classes. Okay, so before knowing chemical formula, you should know some basic terms related to that. First of all, you have to learn atomic number from 1 to 20 with their symbols. Atomic number 1, that symbol is H and name is hydrogen. Atomic number 2, symbol He, name is helium. So in the same way, children, you have to learn the atomic number from 1 to 20 with their symbols and their name. Okay, children? For writing chemical formula, children, you have to know two things. The first is symbol of element and second is valency of element. Okay, children, symbol of element is very easy. If you know the symbol of element, then you can easily make the chemical formula. But children, the second thing is valency of element. In valency of element, you have to learn atomic number of element. You have to know the distribution of electron. So this is a very important in chemical formula. And now I am going to explain about how can we calculate the valency of atom. Okay, see children, I will start from the basic terms. Okay, we will read about some basic terms and after that I will tell you how can we calculate the valency of an element. Children, these are the energy cell. First try to understand. This is the energy level cell. Energy level shell. Okay. The name is this KLMN. According to Bohr-Waring theorem, these energy level cell fill the electron which is present in an atom. Okay, and how many electrons will fill in which cell, it is depend on the formula 2n square. I will tell you about everything in this in chapter 4, children. Okay, so the how many electrons will fill in which cell, it is totally depend on 2n square. If n is equal to 1, children, okay, so we will get the value 2 into 1 square, it means 2. So n is equal to 1 means, children, k cell. So here k will accommodate only 2 electron in their cell. Clear children? Now when n is equal to 2, so we will get 2 to 2 square to the 4, 4 to the 8. Now n is equal to 2 means LCM. So here N will accommodate 8 electrons in their cell. N is equal to 3. We will get 2 into 3 square, we will get 18. N is equal to 3 means M cell. M cell will accommodate 18 electrons in their cell. And N is equal to 4 means 2 into 4 square, 32. It means N is equal to 4, there is N cell. So on the basis of this formula, we have seen children how many electrons will fill in which cell children. Okay, here K accommodate 2 electrons, L accommodate 8 electrons, M accommodate 18 electrons, and N accommodate 32 electrons. Children, there is one also thing that K contains 2 electrons. It may be less than 2, but it cannot above 2 children. Okay? L will accommodate only 8 electrons or less than 8 electrons, but it cannot above 8 electrons. Similarly, M and N cell also, M will fill only 18 electrons or maybe less than 18 electrons, but it cannot be above 18 electrons. Clear children? Now we will see how can we fill the electrons in the various cells. Sodium, atomic number 11 children. Okay, now their cells KLMN. Okay, now there are 18 electrons in the sodium. Students, atomic number also represent number of electrons. Okay, please note in your copy that atomic number of any element represents number of electron in an atom. So there are 11 electrons in sodium. Now distribute these electrons in this cell. 32 children. Now K cell, K can accommodate 2 electrons, so we will fill 2 electrons. Okay, L cell accommodate only 8 electrons, so we fill 8 electrons. Now count this 8 to 10 and we have to fill how many electrons? 11 electrons. The remaining is 1 electron will be in the M cell. Easy children? First example. Second example. Aluminium. 13 children. 13 atomic number 13 is aluminium. Now K L M N. Okay. So first we have to fill how many electrons children? There should be 2 electrons. Okay, because K cell accommodate only 2 electrons. L cell 8 electrons. Now the remaining is 3 electrons will fill in M cell. Clear children? Now note in your copy and I will give you another example to understand this clearly children. See the example children. Atomic number of silicon is 14. Okay. Now distribute their cell K L M N. Okay. Now distribute their electrons in various cells. So K cell contains 2 electrons, L 8 electrons. Now remaining is 4 electrons will fill in Similarly, in oxygen, atomic number of oxygen is 8. So K cell K, L, M, N. So 2, and the remaining is 6 electrons. Fluorine 9, K, L, M, N. 2, and the remaining is 7 electron. Okay children. Now note in your copy children, the last cell first, N is unfilled children, so rub it. M is unfilled, M is unfilled, N is unfilled. Okay, means there are no electrons in these cells. So children, they represent K, L, M, N. All these represent cells, and these represents number of electrons: 2 electrons, 8 electrons, 4 electrons. K, L, they also represent cell, means K, L, M, N, they always represent the cells, and 2, 4, 8, 2, 8, 4, 2, 6, they represent the number of electron in various cells. Now children, one thing you should note you have to note in a copy, that the last cell of an atom is known as valency cell. Okay, or you can say the outermost cell of an atom, that is known as valency shell. Okay, now here M is valency cell, here L is valency cell, here L is valency cell. Concept clear children? The outermost cell of an atom is called valency shell, and the electrons which are present in valency cell, they are known as valency electron. Clear children? So it is known as valency electron, valency electron, valency electron, known as valency electron cell, valency electron. Clear children? Once again I repeat, the electron which are present in the valency cell, they are known as valency electron. Here 4 is valency electron, 6 is valency electron, 7 is valency electron. Clear children? Students, valency electron and valency are not same. Okay, keep in your mind that valency is totally different from valency electrons. Clear? Let's see how can we calculate the valency from valency electrons. Okay, there is one thing children you have to note in your copy, important note, that atom has only one aim. Okay, all atom, okay, I am talking about all atom, they have only one aim. Aim means like we also want to become a doctor, engineer. Okay, so all atom have only one aim. You know what children? All atom wants to become stable. It is also called inert gas. Okay, all atoms, they have only one aim, means to become inert gas or stable. Okay, either by losing electron or by gaining electrons. So children, to become stable, okay, they have to complete 8 electrons in the last cell. Once again I repeat children, To become stable for all atom, they have to complete the 8 electrons in the last cell. Okay, 8 electron in last cell means valency shell or outermost cell. Clear, children? For example, sometimes students get confused about the distribution of electron of calcium. Okay, calcium atomic number 20. Now children, at distribution of calcium, sometimes students get confused. Okay, let's see children. K, L, M, N. There are 20 electrons in calcium. So 2, 8, 2, 8 and M can accommodate 18 electrons. So students are which field 10 electrons in M cell. Okay, according to rule children it is right. But after that, so children, the last cell means M cell can accommodate 18 electrons. So 10 electron is possible. But children, if you look at this, so according to this children, this will wrong. Okay, how? First atom tries to complete its stability by filling 8 electron in the last cell. Okay, first atom tries to complete 8 electron in the last cell to become stable. Okay, so first it will fill 8 electron and the remaining 2 electron will go into another cell. Clear children? So the new distribution of electron will be KLMN 2, 8, 8, 2. Clear children? Potassium also 19 KLMN 2, 8. It will not contain 9 electrons. First, potassium tries to complete its stability by filling 8 electron in the last cell. So there will be 1 8 electron. The remaining 1 electron will go in next cell. Clear children? Now children, see what is valency and how can we calculate the valency of an atom. Okay, students, valency means the number of electron lost or gained to become stable, that is called valency, or another you can say combining capacity of an element is called valency. See children, example potassium. Okay, atomic number 19. So potassium KLMN. Now distribute these electrons to 8. So first it will complete octet, means 8 electron and remaining is 1. Now children, the last cell contains 1 electron. Okay, so we can say potassium is not stable. But if potassium loses 1 electron, means give 1 electron to another, after that the last cell will complete 8 electron and become stable. Clear children? So the valency of potassium will be 1, because there is the definition says that the number of electron lost or gained to become stable, that is called valency. So Potassium lost one electron to become stable. So the valency of potassium will be 1. See the example, oxygen children. Oxygen 8 Kl. Now first it will occupy 2 electron and 6. Children, oxygen also wants to become stable, but children, in the last cell here there are 6 electrons, so it is not possible to lose 6 electrons, children. Okay, so if oxygen gains 2 electrons from other 2 atoms, okay, it needs 2 electrons, because if it gains 2 electrons, so 6 to 8 electrons and become stable. So children, when oxygen gains 2 electrons, after that it will become stable. And now we can say valency of oxygen will be 2, because the number of electrons lost or gained also to become stable, that is called valency. Clear children? These are the some steps how can we calculate the valency of an element. Okay, let's take another example to know how can we calculate valency. One important note, children, to calculate valency. Okay, there are two methods which we can calculate the valency easily. Okay, if an atom contains 1, 2 or 3 electrons in their valency shell, means last cell, so children, same number of same electron will be their valency. For example, sodium, magnesium, aluminum. Atomic number 11, 12, 13. K, L, M. Okay. So first 2 electron, it will accommodate 8 electron, 1 electron. 8 to 10, 10, 1, 11. 2 electron, 8 electron, 2 electron. 12, 2, 8, 3. Now children, the last cell means valency cell contains 1 electron, here 2 electron, here 3 electron. So children, same electrons will be their valency, means valency of sodium will be 1, valency of magnesium will be 2, and valency of aluminum will be 3. Concept clear, children? Second, if an atom contains 4, 5, 6, 7 or 8 electrons, okay, so children, in their valency cell, so their valency will be 8 minus valency electrons, means to calculate their valency we have to subtract valency electrons from 8. Okay, for example, fluorine, okay, atomic number 9, K, L, M, N, 2, 8, 2 or 7. Okay, here children, last cell contains 7 electrons in their shell. So to calculate its valency, we have to subtract valency electron from 8. So when we subtract 7 from 8, so we will get the valency will be 1. Okay, another example you can see, children, nitrogen, atomic number 7, children, K, L, 2 and 5. How many valency will be there, children? Valency will be 3, because we have to separate valency electron from 8. Means 8 minus 5 will be 3, children. For example, sulfur, children, 16, K, L, M, N. 16 is there, 2, 8, 6. Okay. Last cell contains, means valency cell contains 6 electron, children. So to calculate its valency, again we have to subtract from 8. So 8 minus 6. So valency of sulfur will be 2. Concept clear, children? Now children, some valency you have to learn, okay, because the valency can be calculated from above atomic number 20, and that will be explained in higher classes, children. So for right now you have to learn their valency, children. Element cobalt 2 plus 2 means how much charge present on the atom, that will be their valency. Zinc 2 plus, valency is zinc 2. Barium 2 plus 2. Lead 2 plus 2. Copper 2 plus 2. Okay. For example, children, if I tell you write the formula of zinc oxide, okay, so the valency of zinc will be 2. Clear, children? If I say to you what will the valency of barium, then barium valency 2. Iron 2. Copper 2. Ammonium 1. Silver 1. Clear, children? This you have to write because this valency comes from positive charge. Now see in negative charge. Children, first we have to know radical. Radical, and what is the difference between this atom and this radical. Okay, we can see, children, positive charge means only one atom contains positive charge among all these elements. See, only cobalt contains 2 plus, nickel contains 2 plus. Okay, so these are the atom or element. But when a group of atom contains charge, for example, there is sulfur and oxygen, carbon and oxygen, nitrogen and oxygen, phosphorus and oxygen, oxygen and hydrogen, hydrogen, carbon and oxygen. So if group of atom contains charge, okay, this will be radical. Clear, children? And it is also called polyatomic ion. Polyatomic ion, write in your copy. It is also called polyatomic ion, means when a group of atom contains charge, that is called radical or polyatomic ion. See, children, 2 minus means the whole atom of SO4 contains 2 minus charge. CO3 contains 2 minus charge. 2 minus not representing only for a single atom. It is representing for all the group of atom. Clear, children? So learn all their valency. This will help to making the chemical formula. Okay. Now let's start the chemical formula. Now, children, first we will make the chemical formula between two elements. Okay. So you have to learn that first you have to write their symbol, and second is their valency. Okay, should remember this, and with the help of this we will make the chemical formula. For example, aluminium oxide. Okay, aluminium oxide. Now separate their symbol, children. Aluminium is Al, oxide comes from oxygen. Okay, calculate its valency. Aluminium 30, 2, 8, 3. Their valency will be 3, children. Oxygen 8, 2 and 6. So we will calculate this valency from subtracting 8. 8 minus 6 will be 2, children. And now what will you do? These valency will transfer from opposite atom. Okay, 2 will come here, 3 will come here, and the formula will be Al2O3. Clear, children? First example, second example. zinc oxide, or you can say zinc chloride. Zinc chloride. Okay, now separate their symbol. Zinc, Zn. Chloride comes from chlorine. Zinc, I've discussed that zinc contains 2 valency. Now calculate chlorine. 17287. Okay, so their valency will be 8 minus 7 will be 1. ZnCl2. Clear, children? Calcium oxide. Calcium, separate its symbol Ca. Oxide comes from oxygen. So at top 22882. Valency is 2. Oxygen valency is also 2 because we will subtract 6 from 8, 2. Children, if the number of valency will be, if there is similar valency of an element, so it will cancel and the formula will be CaO. Or you can also write 2 comes here, 2 comes here, Ca2O2. Both are correct, children. So it is very easy, children. Clear, children? How can we make the chemical formula between two elements? So many of the questions are given in NCERT and side book. You can practice and ask me the question, children. Now we will see the chemical formula between element and radical. Now see, children, second is chemical formula between element and radical. Okay, in the same way, children, we will write their symbol and second is their valency. Okay, for example, children, potassium sulfate. Potassium sulfate. Okay, so this is element and sulfate is radical, children, which contains SO4 2 minus. Okay, so potassium, symbol of potassium is K and sulfate SO4 2 minus, so its valency is 2. Now calculate the valency of potassium. 92881. Its valency is 1, children. Formula is K2SO4. Okay. Second, aluminium carbonate. Aluminium carbonate. Okay. Aluminium carbonate contains 2 minus. Now aluminium. 13283. 23. See, children, if valency. So children, if there is a chemical formula between element and radical, so valency of aluminum is 3, carbonate is 2. Valency of carbonate will transfer here 2, but when 3 valence electron from transfer to carbonate, children, there is a question: will 3 will goes to carbon or will 3 will goes to oxygen? So children, if there is a radical and we have to transfer the valency, children, so we will make a bracket and write its valency. 3 will here, so first we will make a bracket and write its valency. Okay, this is only in case of radical, children. Clear? Now let's see another example. Calcium hydroxide. Okay, calcium hydroxide. Calcium Ca, hydroxide, children, OH minus. Okay, it is a radical, so minus means one radical. You can write 1. Now find out the valency of calcium. atomic number 20, 2, 8, 8, 2. So children, the valency of calcium is 2. Now, transfer, 1 is going there. So when 2 valency of calcium will transfer to polyatomic ions means radical children, first we will make bracket, okay, and write its valency. Clear children? Third, fourth. Silver nitrate. Silver nitrate. Silver Ag. Ag means plus charge children, so its valency will be 1. Nitrate is a radical NO3. Na3 minus, so we will write valency 1. Both will cancel children, you can write AgNO3. Concept clear children? Thank you.